So you see the name is fast exponentiation. That means you can compute the exponent in a fast way. Right? So the algorithm that I want to show you is used sometimes in the old book. This is also called a square and multiply algorithm. Right? This is an algorithm that is called a square and multiply. So what you do is you square and you can multiply. Alright, so the algorithm actually works like this. So suppose we are to compute a to the power of x modulo n. Right? So this is suppose. The question is this. So how can we do this? So the step is like this. Number one, you need to convert x to its binary equivalent. So x has to be computed to its binary equivalent. And then number two, so in the binary form, in its binary form, then you need to replace 1 with sx, 0 with s. Alright, so that's why this is called square and multiply. So there are only two letters here, sx and s. Alright, so, and then finally you need to compute, you need to remove the first sx, and then you need to compute a to the x according to the sequence provided one by one. Alright, so this is the algorithm. So to show you with some example, let's see with some example. I think we got example, probably you don't know. Let me find some easy number. Example should be easy number. Like for example, 5 to the power of 101 modulo 7, for example. Suppose this is the question. Okay. Alright, so first of all, you need to convert. So this algorithm is a little bit hard, right? A little bit hard. You need to understand this. So basically what the algorithm will say is convert x to its binary equivalent. Here x is 101. In each binary form, replace 1 with sx, 0 with s. Remove the first sx, and then compute a to the x, which is this question, according to the sequence provided one by one. This is one by one. It's binary equivalent. Okay, so what we do is, for example, number 101, we need to change this one to binary. What's the binary of this one? This is 1, 2, 4, 8, 16, 32, 64, 128, right? So that means I will have 1 for 64. So I will have 37 left. That's 32. I have 5 left. Yep. So this is the binary. Yes. Everyone follow? Yes. Okay. Right. So let's do the calculation slowly together. Okay. Slowly together, so you will understand. And then usually when I do this one, sometimes I make mistake when calculating. So we just do slowly. So step number 2, what you do is you need to follow this pattern. For each one, you replace with sx. Okay, 1 you replace with sx. 0 you replace with s, sx, s, sx. The algorithm is very cute, okay? So we should like this. Very cute, this algorithm. And then number 3, what you do is remove the first x. You see, I follow this algorithm. Remove the first x. Alright? And then number 3, what you do is you need to follow this sequence. So that means the question is this one, right? 5, 101, modulo 7. So what you do is like this. 5, okay? Please have a look at the way we do this one, because I think you will not understand this one. So you see that 5, follow this one. This is S, right? S means square. When I have x, this means I multiply with 5. Okay? This one is S, I take this square. This one is S, I have another square. This one is S, I have another square. This is x, I multiply with 5. This is s, multiply square. S square times 5 modulo 7. Okay? Now you need to check. Okay, let's check. This one is 5 square. 5 square multiplied by 1. That means 5 to the 3, yes? And then I take square. That means 5 to the bottom. So this is 5 to the 3 to the 5. So that's square. So that means 5 to the 6. This is 5 squared times 3 is 5 to the 3, right? Square, that means 3 times 2, 6. Yes? Square, that means it's 12. Square, that means 24 times 1, 25. Square, 15. Square again, 100 times 1, 101. You see, follow this one. So this algorithm is very cute. If you follow this one, definitely it's correct. Okay? So you may ask me why we need to do this stupid thing. No, this is not stupid, because this is the way we do this big computation without even using a calculator. Right? Because now I can do this one. I can do this calculation one by one. Okay, so what you do is like this. You start with the innermost, which is this one. 5 square. 5 square modulo 7. 5 square modulo 7. What's 5 square? 25. 25 modulo 7 is 4. Yes? So I put this back. 4, and then times 5. And then this one, I put it back. Square, square, times 5. Square, square, times 5. Modulo 7. Okay? So now you can see that the one that's inside here, 4 times 5, 20. 20 modulo 7 is 6, yes? 6, because 20, 14, 20 minus 14 is 6, right? This is 6. You know, this is 6. Now I put this back. Square, 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 times 5. Square, square, 5. Okay? And now you can see again. Now I do 6 square. 6 square is 36. 36 modulo 7 is 1. Yes? 1. So this one is 1. Square, square, 5. Square, times 5. You can see that as soon as I find 1, I can do this one quickly. Because 1 square, that's 1. Square is 1, right? So you can see that this result, this will be eliminated by 1. So now the next one is 1 multiplied by 5. So I will get, so the next calculation is 5 square, square, 5 mod 7. Everyone follow? So you can see that now, you can see that this number will repeat back. 5 square modulo 7. See, I calculated before. 5 square modulo 7. That was 4. So this one should be 4. 4 square times 5 modulo 7. So now 16. We have 4 square is 16. 16 modulo 7 is 2, right? So this is 2 times 5 modulo 7. That means the result is 3. Is it? Okay, so no matter how big the number is, with this algorithm, you can always compute it. But unfortunately, your calculator cannot compute it. If you ask me, what about if I use computer? Computer cannot compute it either. Has to use this algorithm. Okay, because this algorithm actually works with any number. Meanwhile, your computer, for example, if you are writing with, for example, you use C++, you will have long integer.